In the last video, we talked about the maculae, and the maculae are specific sensory receptor organs that monitor what's called static equilibrium. Essentially, this is just monitoring the position of head in space. So, for example, it plays a role in controlling posture, and it responds to linear accelerations. So that would mean things like moving your head forward and backwards, or um, just standing in an elevator and the elevator moving upwards. But what's important to remember that it is not rotation. So the anatomy of the macula starts with flat epithelial cells called hair cells. And these hair cells, interestingly enough, are embedded in what's called an otolith membrane. It's a jelly-like mass. And the otolith is actually calcium carbonate stones that can actually be dislodged. And when they get dislodged, this can cause things like vertigo or vomiting or other problems. And there's ways that they can be corrected. So the utricle maculae are horizontal with vertical hairs, and they respond to tilting of the head. So it's important to remember this is forward or backward movements that stimulate the utricle. The saccule macule, or maculae, excuse me, and again, the maculae is the name of the receptor, not the specific vestibule. And it responds to up and down movements like acceleration of an elevator. So you're not moving, but you're being moved in a superior or an inferior direction. And these hairs synapse with part of the vestibulocochlear nerve, which, as you know, is cranial nerve number 8. So this shows a little better example of this movement. So this is what we call the vestibular system. And here's the otoliths, the calcium containing structures, and they're going to respond by movement of your head. So here on the right-hand side, we see the head upright or the head tilted forward. When it's tilted forward, that excites action potentials along the vestibular nerve. When it moves backwards, it decreases action potentials in the vestibular nerve. But either way, it activates these receptors called the um, maculae. And there's a macula in the utricle and one in the saccule. But again, this area right here is the vestibules. On our next slide, we now are referring to receptors of the semicircular canals or the cristae. And they are going to be within the semicircular canals, and they're excited by acceleration or deceleration of the head. And it's rotational or angular movement, like twirling of the body, and it would not be static equilibrium. So this is what we refer to as dynamic equilibrium. And on the previous slide for the maculae, that would be static equilibrium. So we have dynamic equilibrium here, and the previous slide was static equilibrium. So again, there's going to be sort of the same functions with similar type jelly-like mass, and those are going to be activated for rotational um, movement. So this is a great slide because it's going to summarize the entire vestibular apparatus. And the vestibular apparatus is equilibrium receptors in the semicircular canals and the vestibular canals. Remember, vestibular receptors are static equilibrium. This would mean moving your head forwards or backwards or in an elevator. Semicircular canals would be dynamic equilibrium, like rotation. So here we're going to see the Crista ampullaris shown, And this is going to be for dynamic or rotational equilibrium. Here we see looks like a figure skater here. And in this case, we can see that during rotational acceleration, fluid is going to be moving in a certain direction. You don't need to know the fluid, but it excites these hair cells. And so basically, fluid moves in a certain direction, and that excites these hair cells and sends an action potential through the vestibular part of the vestibulocochlear nerve. So again, semicircular canals, their function is equilibrium, specifically rotational or angular acceleration called dynamic equilibrium. So I'm going to put dynamic here. And again, the name of the receptor is important to know. It's the Crista ampullaris. For the vestibule, this is going to be within the utricle or the saccule for equilibrium, but it's static equilibrium. So moving your head forward or backwards, or being in an elevator. So again, static equilibrium is for vestibule. Dynamic is in the semicircular canals. And those receptors are called the maculae. So that's in both those situations, information travels via the vestibular part of cranial nerve number 8. The previous part that we talked about for hearing is the cochlear duct, and the receptor is named the spiral organ. You can call it that or the spiral organ of Corti. So either way, but it's again important for you to know the names of those receptors. So we'll take a look at a few different homeostatic imbalances. The first one is called conduction deafness. So where we could use a hearing aid. So it could be impacted by something as simple as impacted earwax, a perforated tympanic membrane, the eardrum, inflammation of the ossicles, so otosclerosis of the ossicles. Or there could be such things as sensorineural deafness, which is a little more complicated, could be damage to neural structures at any point from those cochlear hair cells at the organ of Corti all the way up to the auditory cortical cells, which are in the auditory cortex of the temporal lobe. So they're working on cochlear implants. They do have those, and they're working on making them better and better each day. They've had them for quite a while, and they're so effective that now deaf children can learn to speak. So pretty amazing. The last two are what's called tinnitus. That could be a ringing or a buzzing that you hear, or even a clicking sound in your ear in absence of an auditory stimulus. Could be due to a problem with the cochlear nerve, inflammation of the middle or internal ears, or even something as simple as a side effect of a medication like aspirin. Meniere syndrome is a labyrinth disorder that can affect both the cochlea and the semicircular canals. So remember that the labyrinth is all these different kind of mazes of canals that's in the inner ear, which would be the cochlea and the semicircular canals. In certain cases, there can be displacement of those otoliths, but it can lead to problems like vertigo, nausea, or even vomiting. Some of those anti-motion sickness drugs can help it, or even surgical removal of the labyrinth in severe cases.